Hello everyone, and welcome back to Velocity Launch Systems. My name is Johnny Shaley, and in this video I will be going over everything that I've done to this rocket since my last video nearly a year ago. I have some exciting things and I'm excited to show you. What I have here is a thrust vector controlled model rocket. What is thrust vectoring? Well, thrust vectoring is the process of vectoring the rocket's thrust in order to keep the rocket stable without the use of fins. In order to accomplish this, we use what we like to call the TVC mount, or the thrust vector control mount. This is located at the bottom of the rocket, and it houses the motor of the rocket, and it uses two 9-gram servos to actuate the thrust plus or minus 6 degrees on all axes, giving us, hypothetically, enough control to keep the rocket stable during flight. And though this is great, the thrust vector control mount is useless without the use of the flight computer, which gives us the altitude, acceleration, and orientation of the rocket during flight. And after it is done, after it has gathered all that information, it stores it on an onboard SD card so that we can analyze the data later and make adjustments and changes to any of the programs or stuff like that. And so another question you may have is, what is the point of all this? Why can't we just use fins like every other normal rocket to have ever existed? And I don't really have an answer to that, other than the fact that this is just such a fun experience. It's different, and it's just something that you usually don't get to do. When building rockets, it's usually simple with the fins, but with this, you're able to learn all sorts of Arduino, 3D printing. I would honestly say that this is a more fun experience. So enough talk, let's get right into the details and some of the individual components of the rocket. So what I have here is the most recent design of the thrust vector control mount. For comparison, what I have here is the one in the last video, and some of the most notable differences would be right here in how the arm kind of curves outwards to allow the linkage stopper to better line up with the servo. So that was a huge upgrade. And the overall precision of the new one is a lot higher than the old one, and we now have 6 degrees of range, whereas this one only had about 4 degrees. Hopefully we don't need to actuate that far, but if we do, we have a little bit more range. And this one is just a lot more structural. It's a lot more fluid when it's vectoring, and I feel a lot more confident that this one will hold up better to the static fire test than this one would have ever. So talking a little bit more about this new design, it was designed in Onshape. It's a browser CAD software. It's really easy to use if you haven't used it yet. And it was printed on my Ender 3. It's a great printer. A lot of you ask what printer I use. I use the Creality Ender 3. So you get really precise, and it's a fairly cheap printer, so I highly suggest getting it. And so yeah. So now what I'm going to do is I'm going to plug in the flight computer. I have a program already loaded up to it, and we're going to just plug it into the battery, and we're going to see it kind of do what it's supposed to do. So, alright, so it is not exactly accurate at the moment, but you can see when I move the flight computer back and forth, it adjusts, and then on the same with this axis. So if we hold it still, it should stop. And one important thing to note here is that this is not tuned at all. This is just something I quickly threw together because I've spent all my time trying to get this flight computer to work. I haven't really had time to focus on the actual program. But this kind of just proves that it is getting orientation data, and it is able to do something with that. So, we can kind of turn this around, and yeah. Now we move on to the flight computer, and I'm very excited about this flight computer. It is brand new, has a lot of different components, and overall I am extremely happy with how it turned out. So before I get into the details, I'm going to kind of show you what we had for the old one. So this is the old one right here. Big difference. First off, runs on an Arduino Nano, which doesn't have an SD card slot. It's a lot slower and has a lot less pin output, so it is worse in every single area, and I think it's more expensive. So that was just me not really knowing what I was getting into and getting this. But since then I've upgraded to the TVC 4.1, but we'll get into that later. It has a push button, 2 servo outputs, B&O 055, inertial measurement unit, blue LED, pyro for the parachute, and then this huge thing up here. It's actually meant for a breadboard, but I used it because I couldn't get voltage regulators, or I didn't know they really existed. I was new to circuitry and all that stuff, so I just used this to plug into my 9-volt battery. Oh, and also a buzzer. So that is the old design, and then just kind of a look at the back here. I used solder as my main connection for all the wires, which took hours and hours and hours because I didn't want to have to. I wanted it to be. I didn't want all these loose wires back here. But once I actually put a couple wires back there, I realized that it wasn't going to be a problem. So that is the old one. And as far as this one went, I never really did much with it, because there's just not a whole lot I could do with this. It didn't have an SD card slot, so that eliminated any potential of launching, because what's the point of launching without data? It didn't have a barometer, so I couldn't get altitude data, and the B&O 055, though it's extremely accurate, it's just not that user-friendly, and I really haven't enjoyed my experience with it, but I'm going to hold on to it, and hopefully we can upgrade the new one with the B&O 055 once we learn a little bit more about it. But moving on to the new one, it is upgrades in every area. We now have the TVC 4.1 with an SD card slot, significantly faster, like a ton more pin outputs, so we can hook up as many things as we want, whereas the Nano, we only had about 13 slots to hook up. So I'm going to start at the top here. We have 2 MOSFETs and 2 screw terminals, and that is for dual parachute deployment, so we can have a redundancy in place. So if this first one fails, we can have the second one. So that's for the parachutes. And then moving on, we have an RGB LED, so now we can have any color we want, not just blue. And believe it or not, that's a huge help, because being able to understand where the flight computer is and just kind of being able to understand its status by looking at its color, that's a huge thing. So yeah, RGB LED. We now have a buzzer, same as the old one. Well, actually, I believe this one's the passive buzzer, so we can control its frequency. And then right here, we have the voltage regulator, and this is where it plugs in to the 9-volt battery. It's a rechargeable battery right here, and it's just on this little mount, zip tied to this mount. Flight computer screws in here, but I'll show that whole thing later. Moving down, we have the MPU 6050 inertial measurement unit / accelerometer. So this is already proven to work. It works phenomenally, and way easier to use than the B&O 055, so that's already been helpful. We have the BMP 180, forgot what that was called, altitude sensor, so we can get altitude, and it's extremely accurate. I've already been using it, and I've already enjoyed being able to get some great data from it. Moving down here, we have 3 servo outputs. Right now we're only using 2 for the X and the Y on the thrust vector control mount, but we have a third one here in case we want to do anything else, so room for upgrades. And then we have not 1 but 2 push buttons. So right now I don't even have this one soldered up to it because I haven't needed a second one, but when I do need a second one, it'll be an easy connection, and I'll be able to have 2 push buttons. So, you know, whatever that, we can have 2 programs running. You know, we want to do one thing, we push this one, do another thing, we push that one. So a lot more options. So switching it over on the back here, it is very chaotic, a lot faster to do than the old one because I didn't have to do the solder connections. But overall, I'll zoom in a little bit here. But yeah, I was very happy to see that there wasn't a single short circuit on the entire board. It took me, I want to say, 5 hours to do this whole thing on the back, maybe 7 hours the whole board. So if you're wanting to get into a project similar, that's kind of the time it takes. And at the end of this video, I'll kind of show my setup around here. But this is the new flight computer. One thing brand new to the rocket would be the addition of this downward facing camera located in the airframe of the rocket, slightly above the thrust vector control mount, which is located right down here. It's a run cam. I don't really know the exact name of the camera, but I know it's a run cam, and it gets 4K video, and we'll be able to get some great footage of the launch. So we've talked about what happens on the bottom half of the rocket. Now let's move up to the top half. So this is the avionics bay. It has the flight computer in it, and 2 brackets, 3D printed, center the flight computer, and there's this cutout here so we can kind of access it a little nicer, and we can get in there and push the buttons, and we can see the LED and all that stuff. And then this is the separation point between the avionics bay and what I usually refer to as the payload section, because that's where you usually put the payload. But in my case, with this specific rocket, that is where the parachute is. So I guess you could call it the recovery section. But anyway, that separates. Right here's our piston, but we'll get into that in a minute. Looking at this bracket here, it is a 3D printed bracket. I can go ahead and remove it. Blue tape kind of makes it a little bit more pressurized, so it's the pressure, when this section pressurizes, it's not going to go over. So we have to have a tight fit, so the tape helps with that. And looking at it, we can see we have the metal U-bolt, and shock cord is attached to that. It's tied to it, and there's a bracket on the back, so that is structural, so I don't think that's going to go anywhere. And if it seems to be overkill, I might just make it 3D printed, because the U-bolt is a little heavy. But we could always switch it out if it seems to be too heavy. And then right here, these little wells, that is where the black powder charges sit. So the black powder charge that I'm going to be using, it involves a Christmas light and this little heat shrink tube, and you kind of break the glass on the Christmas light, and then you fill this section with black powder. And when you put 9 volts in here and then you ground it, obviously, it'll catch fire, a little spark, and you have a pressurized chamber. So that is what I will be doing for now. Assuming I can get my hands on some black powder, which is proven to be difficult. I've gone to multiple places in my area, and nobody carries black powder. So it's making me want to switch to a mechanical recovery system, but for now, this is what I have, so we'll go with this. And so yeah, that kind of sits there, and we have 2. We'll have 2 charges, so if one fails, we have another one, or if this one's not enough to separate the section, it will hopefully get it done on the second time. And this is the piston, so it's just a piece of coupler with some tape around it, gives it a little bit more friction, and the shock cord runs right through with a little 3D printed cap. And yeah, so it'll pressurize, and it'll push up through the rocket. And 3D printed nose cone, I've sanded it down so it's a little bit more smooth. Shock cord ties to that. And then right there, I'll let that knock over, we have the parachute. It's from Apogee, 18 inches I believe. And yeah, and then the piston will kind of just push the whole thing through. So that is the recovery system. That's going to conclude today's video. If you haven't already, please subscribe and leave a comment down below with any suggestions or questions about the project or the video. Some things that are coming up is going to be the static fire test, which is pretty much just going to prove if the thrust vector control mount works. That's probably going to be next. And then the launch pad is probably going to be after that. The launch pad is nothing, it's not going to be anything complex. It's simply just going to be a mount that holds the rocket upright before it actually launches, because I really want to focus on getting the rocket to work, and then I can go back and make the launch pad fancy and do all this stuff with that. And then after that, we'll have the first launch. So in just 2 videos, we'll have the launch. At my current rate, that's going to be like 2 years if I make a video every year like I've been doing. So I can't keep that. I'm going to have to make videos a lot more often, and I want to. I'm finally getting more into the project, a little bit more motivated now, especially because I have the new flight computer, so there's actually a chance of doing a launch, whereas the other one, I was just kind of stuck. So now that I have that, we can really make some progress, and I just want to see this thing fly. So I'm going to get to work on that, and let's just get some more videos. So thanks for watching, and have a great day.